In this video, we are going to talk about how to convert a hexadecimal number into a decimal number. Now, remember when I solved octal to decimal method? Well, the solving here is pretty the same, but hexadecimal has a base number of 16 and decimal has a base number of 10. Remember, also hexadecimal has letters on each problem. So 10 is A, 11 is B, 12 is C, 13 is D, 14 is E, and 15 is F. Remember, all letters should be capitalized, not small letters. So let's start by this example. To be 8, the base number of 16. So how can we convert it into a decimal number? We'll do the process here, like we did in octal to decimal. But this time, put 16 here to the power of 0, 16 to the power of 1, and 16 to the power of 2. Now all we need is to solve here the problems, and 2 times 16 to the power of 2 plus 11 times 16 to the power of 1 plus 8 to the power of 16 to the power of 0. Alright, in the last part of the solving system, remember 16 to the power of 0 is equivalent to 1. So 8 times 16 is actually 8. So 2 times 16 times 2 is 256 plus 11 times 16 is 176 plus 8. That's going to be our solution. So now all we need is to multiply these numbers here and add. Alright, so we multiply here, we add these numbers. 256 times 2 is equal to 512 plus 176 plus 8. 512 plus 176 plus 8 is equal to 696. And that's our decimal number in this problem. Remember, decimal number has a base number of 10. Let's try another one. Alrighty here. For this one, convert it into a decimal number, 382, with a base number of 16. Do the same process again. 16 to the power of 0, 16 to the power of 1, and 16 to the power of 2. Alright, we need to solve them again. So 3 times 16 to the power of 2 plus, remember, letter A is equivalent to the number 10. 10 times 16 to the power of 1 and 2 times 16 to the power of 0. So we need to multiply it again. 3 times 256 because 16 times 2 is 256. Alright, now 10 times 16 to the power of 1 is 160. And 2 times 16 to the power of 0, it's only 2 because 16 to the power of 0 is equivalent to 1. Anything that is raised to 0 gets raised to the power of 1. Remember that. So we need to multiply here these problems here, and we add the rest of the problems. So okay, 256 times 3 is 768 plus 160 plus 2 is equal to 930, and that's our decimal number here. Alright, let's try another example. Okay. Anyway guys, you can pause the video if you wanted to solve, or if you want to keep up with my problem. Or you can search rapid tables for your problems, such as 2B8A, like that, and also hexadecimal problems, something like that. So let's move on. Here, try to solve this. Try to convert it into a decimal number. Do it again. 16 to the power of 2 here, 16 to the power of 1, and 16 to the power of 0. Alright, so start here. 9 times 16 to the power of 2 plus, so letter D is exactly the number 13. So 13 times 16 to the power of 1, and letter E is number 14 because that can be found in the ASCII code table. So 14 times 16 to the power of 0. We need to multiply it. We need to multiply these problems here. 9 times 256 plus 13 times 16 is 208 plus 14 times 16 to the power of 0 is 14. Now we need to multiply the first multiply the factors here and add the add-ins here. So 256 times 9 is 2,304 plus 208 plus 14 is equal to 2,526. Alright, so that's our decimal number here. 2,566 to the base number of 10. Now, let's try solving a problem, but 4 digits in a hexadecimal number, like same as before. Let's try this. Alright, 9a7b to the base with a base number of 16. Convert it into decimal number. Start here, 16 to the power of 0. Sixteen to the power of 1. Is 16 to the power of 2. And 9 is 16 to the power of 3. That's number 3. So, we need to solve it again. 9 times 16 to the power of 3 plus a is 10 times 16 to the power of 2 plus 7 times 16 to the power of 1 plus b is 11, so 11 times 16 to the power of 0. And we need to multiply these factors to get, and 9 times 16 to the power of 3 is 4096 plus 10 times 16 to the power of 2. Put 10 here, and 16 times 2 is 16 to the power of 2 is 256 plus 7 times 16 to the power of 1. 7 times 16 is 112, and 11 times 16 to the power of 0 is 11 only. Remember, the last factors here, anything that is raised to the power of 0 can be raised up to 1. Only 1, so it's only 11 here. Now we need to multiply these two factors and add the rest. 4096 minus times 9 is 36,864 plus 10 times 256, 2560 plus 112 and 11. So we need to add them. 36,864 plus 2,560 plus 112 plus 11 is 39,547. That's our decimal number here. Alright, 39,547 with a base number of 10. That's our decimal number in this book. Let's try another one for 4 digits in a hexadecimal number. Oh. Let's try another one here. Eight B 3A with a base number of 16. Anyway, you can pause the video. Oh guys, just like I said before, repeat the process again. 16 to the power of 0, 16 to the power of 1, 16 to the power of 2, and 16 to the power of 3. Alright, so let's solve this again. 8 times 16 to the power of 3 plus b is 11 times 16 to the power of 2 plus 3 times 16 to the power of 1 plus a is 10, so 10 times 16 to the power of 0. Multiply the factors again. 8 times 16 to the power of 3 is 4096 plus 11 times 16 to the power of 2 is put 256 here. 3 times 16 is 48. And 10 times 16 to the power of 0 is only 10. Now we need to do the process again. Like I said last time, 4,956 times 8 is 327,684 plus 256 times 11 is 2,816 plus 48 and 10. Add these add-ins together. So 327,684 plus 2,816 plus 48 plus 10 is equal to wait, we do not include the 4. Made a mistake. So 32,768 plus 2,816 plus 48 plus 10 is equal to 35,642. Alright, we have our decimal number here. My mistake about that, guys, I put 4 here but it was actually a mistake. Now we have our decimal number here, and we're down to our last problem, which is the 5-digit of a hexadecimal number. Anyway, I'll try to solve this on my own, but you can keep up if you pause the video. So, here we go. I have the problem right here, 8B 5DF. I'll try to solve this on my own. The last one here is 16 to the power of 4. The others, I copied all the values. So let's get started by solving. Alright. Wait, no spacing. B is 11. 5. Letter D is 13. and F is 15. Alright, so need to multiply these. 16 to the power of 4 times 65,536 plus 11 times 4,096 plus 5 times 256 plus 13 times 16 is 208. And lastly, put 15. Alright, now we need to multiply the factors and the rest are add-ins here. Put the add-ins in our final answer. 65,536 times 8 is equivalent to 524, 288 plus 11 times 4,096 is 45,056 plus 256 times 5 is 280 then put 208 and 15. Alright, we're down to our final answer. 524,288 plus 45,056 plus 280 plus 208 plus 15 is equivalent to 570,847. And that's our decimal number in this problem. 570,847 to the base number of 10. Alright, now we are done. And yeah, thanks for watching, guys. Next video, I will upload the ASCII code and find the binary. Same problem will be displayed in the ASCII code. So that will be all for today for hexadecimal to decimal, and thank you for watching.